Finally, you have more than an octet, more than an octet. And we call this the expansion of an octet. So you can have 10 valence, 12, 14, seriously, etc. But mostly for this class, usually you're going to see the 10 and the 12. But let's look at it. And this occurs in period 3, nonmetals and beyond. So very critical. Look here. This is period 3. Non-metals. This is period 3 right here, where n equals 3, basically. This is n, remember. This, non-metals and beyond. So that's where it applies. Non-metals and beyond. Can actually also apply here, believe it or not. But anyway, just know that nothing in 2, but in 3 and B and after, you can have more than 8. So let's go back to this. So here's a primary example. PCl5. Let's draw it. P has 5 valence. Cl each has 7. Here, let's verify. P has 5, Cl has 7. So that's a total of 7 times 5 is 35, plus 5 is 40. Good. Put P in the central. However way you want to draw this, it really doesn't matter in terms of how you place them. Give the CLs the octets. And then we'll check if we have or how many electrons we have. Good. Count how many electrons we've used so far. 8 plus 8 plus 8 plus 8 plus 8. That's 40. 8 times 5 is 40. Okay, good. Let's pay attention to P. How many electrons does it have? Has 2, 4, 6, 8, and 10. Has 10 valence electron. So yes, it can go above 8. Why is that? Why is P allowed but not N? Like, for example, you'll never see this. NCl5 does not exist, but PCl5 does exist. Well, it has to do with quantum numbers, and that's why we talked about that. P, let's look at N. N, just quickly, this is an explanation. We have to have the theoretical underpinning of this. P is in period number 3, N is in period number 2. So the principal quantum number is 2 for N and 3 for P. Good. So N is in period number 2, so that's N equals 2. Okay, if N is equal to 2, what could L be? It could be 0, and it could be 1. This is S, and that's P. And we know that the total of electrons for S is 2, for P is 6, because you have 3. So that's a total of 8 valence. But for P is N equals 3, L can be 0, L can be 1, and L can be 2. And this is S, this is P, and this is D. So you can put 2. We already went over this. but just seeing the connection here, and 10 you can put in D. We already did electron configuration. So 2 plus 6 plus 10 is 18. So notice why P can take more than 8, because it has right here, this is the key. It has D orbitals. So if you have anything over 8, they're going to go into the D orbital.